Hey guys, welcome to Pre-Calc lesson 3.2, interpreting infinite graphs. First, let's start with a warm-up from yesterday, interpreting finite graphs. Given this graph on the right, I want to state the domain, the range, where is f of x less than 0, where is it greater than or equal to 0, where is it increasing. And notice up here it says round all answers to the nearest half, use set notation. First thing I want to do is make sure I know what the relative maxes, mins, roots, and endpoints are. It's tough when we make these graphs. Sometimes they're off just a smidge. But I'm going to highlight these coordinates here that I'll be using to answer these questions. So first of all, state the domain. We know domain, the x values, right? So it looks like from here to here, this interval will be the domain, -5 to 6. -5 is less than or equal to x is less than or equal to 6. State the range. Well, the range, the y values. So you don't necessarily use the endpoints. And actually, in this graph, we're not using the endpoints at all for range. It's the maximum and the minimum. So from here, looks like -3 to 6. This is the range. And it's going to be the y values. All right, so -3 is less than or equal to y is less than or equal to 6. Next, where is f of x less than 0? That means below the x-axis. All the pieces below the x-axis. Well, there's only one. And notice, if this was or equal to, it would be a lot more complicated because I have all these points that are or equal to. But it doesn't. It just says less than 0, so it's just this interval here, open circle in between. All right, so that's going to be -2 is less than x is less than 2. So the next one, where is it greater than or equal to 0? That is above or on the x-axis. Okay, so I'm including this piece here and all the way actually to there. So this whole thing is actually one interval. And then from here to here. Both of those pieces are above or on the x-axis. So I've got -5 is less than or equal to x is less than or equal to -2, or 2 is less than or equal to x is less than or equal to 6. That represents those two intervals. Where is f of x increasing? Increasing means going up on the roller coaster. So as you go here, down, down, down. This is going up, so I want this piece. And then this is down, and then this is up here. So open circle, that's where it's increasing. Open circle, that's where it's increasing. Remember, never include the relative maxes or mins. All right, so this is going to be -4 is less than x is less than -3. Or 0 is less than x is less than 4. Those are those two intervals where the function is increasing. And the next one, where is it decreasing? Well, decreasing means going downhill. So that would be this interval. There it's decreasing. Here it's decreasing. And here it's decreasing. Those are the three pieces where it's decreasing. So I need to get all these intervals. This interval here. This interval here. And this interval here. All right, so there's going to be 3 of them. It's going to be a little bit of a pain to write, but we can do it. -5 is less than x is less than -4, or -3 is less than x is less than 0, or 4 is less than x is less than 6. Those 3 intervals are where it's decreasing. All right, so that's just a review of yesterday. Now we're going to start talking about infinite graphs. And what we're going to have to do here, and I apologize in advance, I can't show you the calculator. I'm assuming you guys can all put this into Y1. But if you're having issues with this, please just reach out and let Mr. Ward or myself know. We're going to put this into Y1. Okay? And then I need to take a look at this graph, and I need to get specific coordinates. I need to get the relative maxes, the relative mins, and the roots. Now, a quick reminder here. When it comes to graphing these, you need to be able to adjust your window to see the whole graph. So if you need to move to the right, you're going to increase x max. If you need to move to the left, you're going to decrease x min. If you need to move the window up, you're going to increase y max. If you need to move the window down, you're going to decrease y min to make it fit. Usually, you're going to have to adjust the window to make it fit because you're not going to see all the relative maxes or mins, okay? All right, so I'm going to put that into y1. I'm going to show you a sketch of my particular graph. Okay, so I get something that kind of looks like this after I've adjusted the window. And I'll show you guys what my window was. And notice now I'm going to put arrows on the end because it doesn't give us a restricted domain. So my window up here was about 75. So that would be my y max. Down here, I think I did negative 100. I just kept playing around until I could see the whole thing. All right, I knew it was a cubic. I knew it had one relative max, one relative min. So I need to see those. I need to see all the roots. Here, I think this was just 10. And over here, I believe I just left that negative 10 because I could see those. So it just kind of gives you an idea what I adjusted. I adjusted y max. I adjusted y min. I left x max and x min alone. All right, so I highly recommend that you put in a y2 equals 0. You don't have to write it out. I'm just showing you I did that so that you can find your roots. All right, I use second calc intersect. I just think that's a little bit faster. If it doesn't say what to round to on this type of problem, usually you'll say like nearest 10th. Let's go to nearest 10th. So for this coordinate down here, my first root, I got negative 3.6, comma 0. For my next root here, I got 0.1, comma 0. It's just to the right of the origin, so you can't use 0, 0. It doesn't go through the origin. And then this one over here, I got 5, 0. Now, I need to get my relative maxes and my relative mins. Here's a relative max. So on this, you have to go through the procedure, second calc, and then find a max. It's going to ask for a left bound, then a right bound, then a guess. So you have to come up with that coordinate, and that was negative 249. And then my relative min, you have to do the same thing. Second calc minimum, it's going to ask for a left bound, then a right bound, then a guess, and it'll say min. This was 3, negative 76. So we have to do a lot more work with these problems before we can answer the question. We have to get it on paper from our calculator, and we have to find all of those coordinates. So now the rest should be pretty straightforward. It says find all relative maximum coordinates. Now remember, a relative maximum has to be a peak. There's only one right there. So that's going to be negative 249. Okay, next, find all relative minimum. Relative mins be your valley right there. Again, there's only one of them. It's this one right here, negative 376. And find all roots. We've already done that. I just like to list them x equals. You can use set notation, so that's negative 3.6, 0.1 to the nearest 10th, and 5. Okay, let's move on. Tackle some that are maybe a little bit more challenging. All right, graph f of x equals negative x to the fourth plus 12x squared plus 16x. Again, what you need to do is you need to put all of this into y1. All right, I will show you my sketch and kind of give you an idea of the window I used. So another thing to kind of keep an eye out for, that's a fourth degree. Remember from last year, fourth degree, it's going to look like this, or it's going to look like this. And because it's negative, tails are going to be down. We're going to talk a lot about this later in the unit, but that's just something you might remember from last year. So I got a sketch that sort of looked like this. All right, and to give you an idea of my window, I actually did not adjust my x min or x max. I left those at negative 10 and 10. For my y max, I did have to go up to 100. And for my y min, let's see, I didn't adjust that at all, actually. I kept that at negative 10. Okay, so the points we need to get. I need to get this coordinate here because it looks like that's a root. I need to get to relative min. There's another root there. There's a relative max there. And then there's another root there. Again, please make sure, don't assume it hits at an integer coordinate. Put in a y2 equals 0. Do your second calc intersect just to verify. So this root here, I got negative 2, 0. My relative min here, I got negative 0.7, comma, negative 5.6. That did go through the origin. I verified that, second calc intersect. My relative max up here, I got 2.7, comma, 77.6. And then this root was 40. Okay, so now that I've done all of that work, obviously it takes me a little bit longer than that. Find the relative maximum. Relative maximum are your peaks. There's two of them. Here's one peak. Here's a second peak. So I just have to write those coordinates down. So that's negative 2, 0. And 2.7, comma, 77.6. Find all relative minimums. Those are our valleys. I have one valley right there. That's it. It's the only valley I see. That is negative 0.7, comma, negative 5.6. Find all the roots. Roots are easy. It crosses the x-axis, so I have 3 of them. I got x equals negative 2, comma, negative 0.7. Oops, sorry, that's wrong. 0. I'm looking at the wrong thing. Negative 2, 0, and 4. Where is f of x increasing? That means going up on the roller coaster. Well, notice this. Increasing here, and that's it, those two intervals. Now, this is where it gets a little bit weird. It doesn't specify, set notation or interval notation, so I technically could have used both, but it's increasing on this interval. Well, the interval is actually x is less than negative 2. You might think, well, that seems kind of weird. That means going to the left. Well, for all the values that x is less than negative 2, my function is going to be increasing. So that's the first one. X is less than negative 2. Or, so now I have to express this interval. Well, that x value right there is my negative 0.7. That x value right there is my 2.7. So now I need to describe an interval between those two. So that's going to be negative 0.7 is less than x is less than 2.7. This interval here represents that piece that's increasing. This interval here represents that piece that's increasing. I got it covered. Where is f of x decreasing? Going down. So it's decreasing here, that interval, and it's decreasing here. So how do I write those in set notation? Well, that first one is going to be negative 2 is less than x is less than negative 0.7, or when x is greater than 2.7. So if you kind of look, this interval is this piece right here, decreasing from negative 2 to negative 0.7. The other interval decreasing is this one here, which is basically going to be x is greater than 2.7. All right, so now here's one we have to do on the calculator, but it's not infinite. Because notice it says over the interval negative 8 to 8. So we have to put this into our calculator. We're still going to do y1. So I'm going to put all this into y1. But when I give you an interval, here's an easy way to deal with it. Let's make this x min, and let's make this x max. Because then my picture will align with this closed interval. I might need to adjust y min and y max, sometimes quite a bit, but at least I'll know my endpoints. Oops, get my pen here. So let me show you what my sketch looked like. Okay, and to give you an idea of my window, obviously I told you this was 8, and this is negative 8. Now this one I had to really adjust, and it took a little while, but my y max I made 500, and my y min I settled on negative 400. I had to make sure I saw this peak and I saw that valley, so I just kept adjusting those until I got those into view. All right, so now, how do we get these coordinates right here. Because they're not maxes, they're not mins, they're not roots. Well, to be honest with you, it's super easy. You just go to your table because you know the x value is -8. All right, so I just went to my table for those. And for this one here, I got -8, comma 128. The one on the right end was 8, comma 256. Sorry, I'm looking at my calculator as I do this. I verified using second calc intersect in a y2 of 0 that indeed did go through the origin, so don't assume it, especially when we have to zoom out so much. Then I used second calc maximum, left bound, right bound guess to get this relative max, which was -5, comma 425. And I did something similar with minimum here, and I got 4, comma -304. So that's quite a bit of work, right? You have to do a bit of work to get all of these coordinates, all right? But when you're given a closed interval, set your x min and x max. All right, find all relative maximums. Those are our peaks. There's one peak, that's it. It's the only one. That's -5, 425. Find all relative mins. Those are the valleys. I only see one right there. That is it. Remember, these can't be relative maxes or mins because I don't see what's on the other side of those. It has to be a peak or a valley to be a relative extrema, what we say. So this one is the minimum right there. 4, -304. Find all the roots. That's pretty easy. There's one here, and there's one there. I forgot to get that one. All right, so looking at the graph now, I realize I forgot to get that. So I'm going to have to go back in and find it. I get x equals 0. Let me go back in the calculator and do second calc intersect. That ends up being 7.0. It's not exact, but 7.00. 7.0. Where is f of x that's greater than 0? So remember, greater than 0 means above the x-axis. So notice, all of this is above the x-axis. Not that point, though. So that's got to be open circle, but this one's got to be closed because that's above. And this here, oops, just erased that by accident. This here is also above. All right, so my interval is going to be -8 is less than or equal to x is less than 0, or 7.0 is less than x is less than or equal to 8. And that's where it gets a little confusing because this point is above 0. That's why I said or equal to. That point is included. This point is above 0. That's why I included that. But the roots are not. That would be an open circle, and that one would be an open circle right there. So the last one, where is f of x less than or equal to 0? All right, so less than or equal to 0 is down below. And it says or equal to, so I'm going to include these two roots. All right, and there's only one interval there. It's pretty easy. That's going to be 0 is less than or equal to x. It's less than or equal to 7, or 7.0. Okay, we got one more. This is another infinite graph, right? It doesn't give us a restricted domain. Notice it just doesn't say anything here. All I have to do is put this into y1. And I might need to adjust my window. So let me show you what my graph looks like. I get something that kind of looks like this. And again, just a reminder, this is a cubic function, right? We talked about our parent functions in the beginning of the year. For a cubic, I'm expecting something that looks like this. So if you look at your window and at first you just see something maybe, I don't know, something crazy, you know you're going to have to adjust it. And usually for a cubic, it's a good idea to adjust your y max and your y min if necessary. All right, so let me write down what I got. First, I found my roots. Second calc intersect, I had a y2 equals 0 to the nearest tenth. This one was -3.9, comma 0. This one here was just to the right of the origin, was 0.2, comma 0, and that's why you have to go through that process. Don't assume it's the origin. And then this one here, I got 2.0, comma 0. Next, I define my relative maxes and mins, second calc maximum, left bound, right bound guess. And for that one, I got negative 2.3, comma 52.5. And this one right here, I got 1.2. I did second calc minimum, comma negative 12.6. I forgot to tell you guys what I did for my window. I just kept this at 10 and negative 10. You can actually make that a little bit smaller and get a better picture if you wanted. Notice my maximum was 52.5, so I went up to 75 here before I could see it. And down here, I just went down to negative 20. That's what I did for my window. Okay, where's f of x greater than or equal to 0? That means above or on the x-axis. Above or on the x-axis. So that's this piece right here. And it's this piece right here. Now I'm going to use interval notation. We haven't done interval notation yet today. Some of you will prefer it if it doesn't specify. It's your choice. So I want x values here, so it's important you write x as an element of. Then I'm going to use a bracket, negative 3.9, comma 0.2 with a bracket. And the reason I'm using brackets is because it says or equal to, so I'm including these roots. What I just wrote down in that interval represents this. Okay, union. What was the other interval where it's greater than or equal to 0? It's this one. All right, so that's going to be another bracket, 2.0, comma, infinity with parentheses. Infinity will always get parentheses. Okay, next one, where is it less than 0? That means below the x-axis. So this is below here, and all of that is below there. So I need to represent these two intervals. Okay, x is an element of. Parentheses, negative infinity. Remember, you always write the lesser of the two first. So this is actually negative infinity over here. And it goes to negative 3.9. And that's a parenthesis because it doesn't include it. Notice this right here, just less than. Union, all right, the other piece that's below is going to be parentheses, 0.2, comma, 2.0 with parentheses. Next, we have increasing. That means moving up. Increasing. This whole piece here is increasing, and this whole piece here is increasing. So I need to represent these two intervals, negative infinity to negative 2.3 and 1.2 to positive infinity. All right, so x is an element of parentheses, negative infinity, but now we're going to negative 2.3, parentheses, union 1.2 to positive infinity. And lastly, where is it decreasing? We have one interval of decreasing. This is it right here. That's the only place it's decreasing. So open circle there, open circle there. So I'm talking about from negative 2.3 to 1.2 with parentheses. X is an element of the interval negative 2.3, comma 1.2. Okay, guys, that concludes day 2. Thanks for watching. And as usual, if you have any questions, don't hesitate to reach out.